If you're aiming for a grade 9 in your GCSE Maths, or you're just curious about what a grade 9 question looks like and how to answer it, then this video is for you. I'm going to go through these 4 grade 9 questions and I'm going to show you the skills and techniques you need to answer those types of questions. I'll put links for the timing below if you just want to jump ahead to a particular question. I also want to point out that by far the best way to improve your maths is to practice maths. And that's true for all maths topics. So to help you with that, I've put together a collection of similar questions to the ones I do in this video over at my website, mathskitchen.com, so that you can get the maximum benefit from watching this video. The questions over there are all automatically marked so you can see how you're getting on as you work through them. One final thing before we get into the questions, these are grade 9 questions, so don't be worried or put off if you find them difficult. You know, they're supposed to be. They're the hardest questions in the exam. So if you are really keen, but you're struggling and you're not quite there yet answering these kinds of questions, then I recommend you practice these, the underlying skills that will help you answer these kinds of questions. For example, solving quadratic equations. And again, I put a link below. You can head over to Maths Kitchen and practice those underlying skills. So they're a bit easier than the ones in this video, but they're the perfect stepping stone to get you to those harder questions. Right, let's get into the questions then. You can tell from the fact that there are 2 inequality symbols that this question is all to do with solving 2 inequalities and then combining the solution. So you see questions like this towards the end of the GCSE paper, and although they might be written in a slightly different format, the fundamental techniques will be the same. So in this case, one of the inequalities is a quadratic. You can see it's got that n squared there. And solving that is really the hardest part of this question. There's a technique to solving those that you need to know, and I'll go through that in just a moment. But before that, let's get the linear inequality out of the way. So this is reasonably straightforward. You would just solve it using the same technique you would for solving a linear equation. So we've got 3n add 2 is less than 14. Let's subtract 2 from both sides to get 3n is less than 12. And then if we divide both sides by 3, we get n is less than 4. So we know we are looking for integers that are less than 4. Let's deal with the second part, the quadratic. There's a really specific technique to doing this. And if you haven't met it before, watch me go through it and then make sure you practice doing that. So to solve a quadratic equation, or inequality as we have here, we rearrange the expressions to be equal to 0. And I'll do that by multiplying both sides by n squared add 5. That gives 6n is greater than n squared add 5. Now I'm going to subtract 6n from both sides. That gives me 0 is greater than n squared minus 6n add 5. Now, if 0 is greater than n squared minus 6n add 5, logically we could say that n squared minus 6n add 5 is less than 0. And I like to rewrite it so that the 0 is on the right. You don't need to do that, but I find it makes it much clearer what the algebra means. This expression here is less than 0, and it leads to fewer mistakes. When solving quadratic inequalities with this technique, you need to be able to sketch quadratic graphs. Doing it this way is again most likely to be successful. So if we were drawing the graph of this quadratic, it would be the graph of y equals x squared minus 6x add 5. And if we were to plot that graph, the 2 solutions would be here and here, where that line crosses the x-axis. In other words, it's at 0 on the y-axis, where y is equal to 0. So those solutions are where x squared minus 6x add 5 is equal to 0. To find the coordinates, we need to solve this quadratic equation, which is technically different to the inequality, but we're doing it like this just to find the points on the graph we're interested in. So factorize to give x minus 5 and x minus 1 is equal to 0. And then the solutions to that would be x equals 1 and x equals 5. That tells us that those 2 points will be at 1 and 5 on the x-axis. Let's relate that back to the inequality we're trying to solve then. The inequality says n squared minus 6n add 5 is less than 0. So we're looking for the places where the y coordinates of the line are less than 0. In other words, where the line dips below the x-axis. All the y coordinates are less than 0 below that line. So that's the part of the graph that's highlighted here. The x-coordinates for all of those points are going to be between 1 and 5. Therefore, the solutions to our inequality will all be between 1 and 5. Another way to think of this is if you were to substitute values back into that quadratic inequality, substituting anything between 1 and 5 would give you a result of less than 0, which is what we're after. If you substituted in 1 or 5, you would get an answer of exactly 0. And in this question, we are only interested in values that will result in an answer less than 0. So we won't include 1 or 5. We could write that like this to show that n must be between 1 and 5. The integers between 1 and 5 then are 2, 3 and 4. However, in order to also satisfy the first inequality, we're looking for integers that are less than 4. And that leaves us with just 2 and 3. So 2 and 3 are the possible values of n that satisfy both the inequalities. There are a number of these harder questions involving surds that might come up in the GCSE exam. And for these later questions with surds in them, you need to be comfortable manipulating surds, rationalising the denominator of a fraction with surds, and then you might need to add, subtract or multiply fractions involving surds. So here we're told that 4 root 14 over root 3 minus root 7 over root 6 can be written in the form c root d over 6, where c and d are integers, and then find the value of c and d. So this says when we carry out the calculation, we get an answer, and the examiner is looking for the answer to be in a very specific form, the one that they describe there. So to add or subtract any fraction, we need to find a common denominator. And in this case, because we're dealing with surds, this may well involve rationalising the denominator. So I'm just going to rationalise the denominator in both of the fractions. So let me show you how to do that. In the first fraction, the denominator is root 3. So to rationalise that, we're going to multiply by root 3 over root 3. That doesn't change the value of the initial fraction in any way. Root 3 over 3 is just 1. So all we're doing really, effectively, is multiplying it by 1. But we are rewriting it as an equivalent fraction whose denominator will no longer be a surd. Okay, so if we carry out that multiplication, the numerator becomes 4 times root 14 times root 3. And root 14 times root 3 is root 42. So we get 4 root 42. And the denominator is root 3 times root 3, which is 3. So that whole fraction is now 4 root 42 over 3. The denominator is no longer a surd. It's 3, which is a rational number, hence the phrase rationalising the denominator. Let's do the same for the second fraction. So here I'm going to multiply top and bottom by root 6, because the denominator is root 6. So the numerator becomes root 7 times root 6, which is root 42. And the denominator is root 6 multiplied by root 6, which is just 6. The calculation is now 4 root 42 over 3 minus root 42 over 6. This is starting to look a lot more manageable now. So when adding fractions, as we mentioned, we have to have a common denominator. And if we multiply the numerator and the denominator in that first fraction by 2, that will give us an equivalent fraction with a denominator of 6, the same as the second fraction. So multiplying the numerator by 2 gives us 8 root 42, and obviously multiplying that denominator by 2 gives us 6. So the calculation is now 8 root 42 over 6 minus root 42 over 6. 8 lots of root 42, take away 1 lot of root 42, in other words. So that gives us 7 root 42 over 6. So our answer is actually already written in the format the examiner wanted. So we were asked to find the values of c and d. So c will be 7 and d will be 42. We have a question to do with proportion here, and as with all of these level 9 questions, if it appears in an exam, it may look different to this, but there are going to be these fundamental underlying skills and techniques, and I'm going to outline them here that will help you even if the question looks a little bit different. The key here is that we're told the relationship between x and y and between Z and X, but in order to answer the question, we need to establish the relationship between Y and Z. So let's start by writing an equation to describe the relationship between X and Y and Z and X. Normally, we would write it like this. We would say Y equals K over root X. And for the second one, we would say that X is equal to KX squared. Now, we typically use the letter K here for the multiplier, but in this instance, the multiplier may well be different in both instances, and we can't have one letter describing two different numbers. So instead, what I'm going to do here is I'm going to use K for the first one and C for the second one. So we've got this link between X and Y and Z and X, and what we want to do is combine those to establish the link between Y and Z. And the way I'm going to do that is I'm going to rearrange the first equation to make X the subject, and then I'm going to substitute that into this second equation, the one where Z is equal to CX squared. And by doing that, we'll end up with a formula that links Y and Z. So I'm going to start by squaring both sides. So squaring the left-hand side gives Y squared, and if I square the right-hand side, don't forget I've got to square everything, I'm going to get K squared over X. Then I'm going to multiply both sides by X to give me X Y squared is equal to K squared, and then I'm going to divide both sides by Y squared to give us X equals K squared over Y squared. By substituting that into Z equals CX squared, I'm going to end up with a formula that links Z and Y. So Z is equal to C multiplied by X squared. So let's substitute in the K squared over Y squared for X. That becomes C multiplied by K squared over Y squared. But then I need to square that because the X that we're replacing was being squared. So if I square K squared, I get K to the power of 4. Because K squared times K squared is K to the power of 4. And similarly, Y squared is Y to the power of 4. We now have C times K to the power of 4 over Y to the power of 4, which can be written like this. C, K to the power of 4 over Y to the power of 4. Now we've got a formula that links Z and Y. All we have to do is calculate C times K to the power of 4, and we'll be virtually there. We're given values of Y and Z in the question, so let's substitute those in order to calculate C times K to the power of 4. When we substitute those in, we get 0.05 is equal to C K to the power of 4 over 10 to the power of 4. And I'm going to multiply both sides by 10 to the power of 4, which is 10,000. So 0.05 multiplied by 10,000 is 500. So C K to the power of 4 is 500. Now we've got the formula that we can use that links Z and Y. The question asks us to find Z when Y is 2, so all we've got to do is substitute 2 into that formula. And if we do that, we get Z is equal to 500 over 2 to the power of 4, which is 16. And that gives us a final answer of 31.25. Questions like this require us to have a good understanding of probability. You need to know how to calculate the probability of combined events. In other words, when there's more than one thing happening. But also, and the thing that makes this a level 9 question is you need to have the ability to set up and solve equations to describe those probabilities algebraically. As with all of these, the questions in the exam may look slightly different to this one, but these are the skills, the underlying skills that you'll need, and I'm going to show you how you can apply them to this particular question. So in this example, we're told that there are 10 red balls and an unknown number of blue balls in a bag, and that if we took 2 of them from the bag, the probability of getting 2 different colors would be 50 over 119. And we need to find how many balls there are in the bag in total. So we're trying to calculate the probability of choosing 2 different colors. So I'm going to start by describing the probability of getting a red ball followed by a blue. We'll also need to calculate the probability of the other way around, of blue followed by red, but I'll come back to that later. We're told that there are 10 red balls, and we would calculate the probability of getting a red from the bag as 10 out of the total number of balls that there are. Now, we don't know the total number, so we need to decide on a way to describe this algebraically. I'm going to describe it as the number of red balls add the number of blues. And we know that there are 10 red balls, so I could describe the total number as 10 add b, where b is just the number of blue balls that we've got. So the probability of that first ball being red is 10 over 10 add b. And to find the probability of getting a blue ball with the second pick, we would say it's the number of blue out of the total number. So don't forget, the number of balls has now reduced because this is our second pick. We've already taken one out. So the probability is b over 9 add b. If we multiply those two fractions together, then we get 10b over 10 add b multiplied by 9 add b. And expanding those brackets gives us 10b over b squared add 19b add 90. So that's the probability of getting a red followed by a blue. But we also need to calculate the probability of getting a blue followed by a red. And in fact, the probability of that is exactly the same. So all we have to do is multiply the probability that we just worked out by 2. That gives us 20b over b squared add 19b add 90. Now, we're told in the question that the probability of getting two different colours is 50 over 119, so we can now set up our equation. And that gives us 20b over b squared add 19b add 90 is equal to 50 over 119. So that's the first key skill that you need to be able to solve these problems. It's the ability to describe these probabilities algebraically and then to set up the equation. We also need to be able to solve the equation, so that's the next skill that we're going to look at. You can see that we've got this quadratic expression in the denominator of the left-hand side, and in order to solve a quadratic equation, we make them equal to 0. So I'm going to rearrange all of this so that I have a quadratic equation that is equal to 0. And I'm going to do that by multiplying both sides by 119. That gives me 119 times 20b over b squared add 19b add 90 is equal to 50. Let's multiply both sides by b squared add 19b add 90. So the left-hand side is now just 119 multiplied by 20b, which is 2,380b. And the right-hand side becomes 50b squared add 950b add 4,500. And if you're comfortable with it, it's fine to combine both of those last two steps into one. So we're nearly there, but it's still not equal to 0. So to do that, let's subtract 2,380b from both sides. That gives us 0 is equal to 50b squared minus 1,430b add 4,500. And we can simplify this a bit by dividing everything by 10. That gives us 0 equals 5b squared minus 143b add 450. Now we can solve the equation. We could use a quadratic formula at this point, but in fact this equation factorizes, as will all of these types of questions where you know you're going to end up with a whole number solution. We're looking for the number of balls, so it's not going to be a decimal. And given this could very possibly be in a non-calculator question, you're going to want to be able to factorize these harder expressions. Okay, it's a good skill to have. I'm not going to go through it now, but as before, I'll put some links below if you want to practice that particular skill. In this instance, it factorizes to 5b minus 18 and b minus 25. So if 5b minus 18 is equal to 0, 5b will be equal to 18 and b will be equal to 18 over 5. Or b minus 25 is equal to 0, in which case b will be equal to 25. B is describing the number of blue balls in this bag, so it must be 25. It can't be 5 over 18 because we can't have a fraction of a ball. So the only thing to finish off then is just to make sure that we've read the question correctly and that we're giving the answer that is required. And in this case, we were looking for the total number of balls in the bag. So there were 10 reds. We were told that in the question. We've just calculated there are 25 blue. That gives us a total of 35. So, as I've said, make sure you practice these. Head on over to mathskitchen.com to do that. Links below, and I will see you in the next video.